Hi, this is Fred Marshak, and this is Chapter 14C, The Outer Planets. Uranus is the first one we're going to be taking a look at. Up in the sky at night, it would look like a tiny little blue-green object. It was discovered by Herschel in the late 1700s, but it wasn't until we had some spacecraft that we learned its true nature. The blue color is from methane. Methane absorbs red light and therefore reflects blue. The same with Uranus and Neptune. Uranus is actually laying on its side. So as it goes around the solar system, it has the most extreme seasons of any other planet. It's actually a little past perpendicular. So it, like Venus, is a retrograde rotating object. We've used Uranus in a number of ways over the years. One is the planet Uranus went in front of a couple of stars. This is called an occultation. And in an occultation, we have the situation where the planet actually blocks out the stars. So there's the planet blocking out a star, and you'll notice you can see the star moving across the top of the planet. Why? Because the planet is mostly atmosphere. The second star it's going to move in front of is, you'll see it actually move along the bottom of the planet. Again, it's bent because of the atmosphere of the planet. So what can we get out of occultations? What can we get out of a big object going in front of a little one? We can get a couple of things. We can get the mass of those objects, and we can also get their exact diameter. And this helped us as we were taking a look at the planet Uranus and with some other ones you'll see later also. Uranus has some rings. We found many, many moons. You only need to know one of them in particular. The one in particular is called Miranda. Miranda has a number of different surface features that don't seem to fit together. That's because it was probably broken up, hit by something, broken up, and then came back together again. Moving on to Neptune. Again, another blue object. Blue because of that methane absorbing the red light and reflecting the blue. It's the first one to be found mathematically due to perturbations, or these abnormalities caused by the pull of other planets. We see that it had a spot. Now we see that it doesn't have a storm. It was actually at the same place that Jupiter's red spot was. Has a number of moons. You only need to know one of them. The one you need to know is called Triton. And Triton has a retrograde orbit. It may have been a KBO. Those will come in a few minutes. But it does have an atmosphere. And in the case of Triton, when the sun lights on it, it actually has some of these dark areas. They're shadows of geysers. We'll talk about those in a minute, or water volcanoes. But in the dark side, it gets so cold that it actually freezes the nitrogen onto the surface. So we have vast lakes of solid nitrogen that has been frozen there. Much, much colder out in this part of our solar system. So as we take a look at this JPL simulation, we'll also see that as we look down on this sunlit side, we'll be able to see some of those shadows cast by these ice volcanoes, as they're sometimes called. And this is an artist's rendition of one of them, not a real image, of course. Neptune also has rings. The rings look like they're in pieces. Really, they're continuous. And one of the last pictures taken by spacecraft is a crescent Neptune in the foreground and a crescent Triton in the background. Let's move on to Kuiper Belt objects, KBOs as they're called. These are beyond the orbit of Neptune. Clyde Tombaugh, and you need to know this date of 1930, he's the one who discovered Pluto. Pluto is the most famous KBO object. Here it is marked with arrows. Aren't you glad there are arrows? You'd never find it otherwise. And actually, we found later on that it moves, of course, relative to the stars. And that's how he found it. You would take a couple pictures and you'd blink them back and forth and actually see that it moves back and forth. It actually moves through appears to move through the stars. That's how it was found. We have exact diameters here, and we know it actually came within the orbit of Neptune. You don't need to know the dates, but from 1978 to 1999, Pluto was actually closer than Neptune. They will never hit each other because the orbit of Pluto is tilted about 17 degrees. Now here are pretty exact sizes of Pluto and one of its 3 moons. How do we get that? An occultation again. Several years ago, actually a decade or so ago, Charon, the moon of Pluto, actually went in front of the planet, in front and behind. That's an occultation again. We were actually able to get very good diameters of both of those objects. Here are actual images of the moon in the upper left and then Pluto in the centers of both of these things here, one rotating, one not rotating. So we know that Pluto has some features, and it'd be really nice to see those features. Through modern astronomy, we've been able to take a look and see that Pluto really has 3 moons. You do not need to know the names of all 3 moons, but this is the discovery image. They were at first, of course, suspected of being moons, but now they've been confirmed. So it just isn't Pluto and Charon. Now it's Pluto, Charon, and we now have Nix and Hydra as the other 2 moons. So Pluto has 3 moons. We're going to have a Pluto encounter in July of 2015, so we may have some good images of Pluto and its moon there. Why is Pluto not a planet? It's his fault. It's Mike Brown's fault. Why? Because down near San Diego, near the Palomar Observatory, there's a telescope dedicated to finding Kuiper Belt objects. And so it works something like this. You'll see one of these objects. The one you need to know is Eris. It's larger than Pluto. That's why a decision had to be made as to what Pluto is. So here's Eris and its moon. It does have a moon, and it's larger than Pluto. There's an object to the center left. Watch it again. There, it just moved a tiny little bit. You may want to replay that to find it. That's how these things are found. How many have we found? We found over 1,000, and we're still counting. It's sort of like the asteroid, another asteroid belt is what it essentially is. So the sun has 2 rings. It has an asteroid belt and a Kuiper belt.